Good afternoon from the International Space Station Flight Control Room. This is Mission Control Houston bringing you live coverage today of the launch of Northrop Grumman's 13th cargo resupply mission to the International Space Station. You are looking live at the Mid-Atlantic Regional Spaceport of NASA's Wallops Flight Facility in Virginia, where the Antares rocket stands ready to launch a Cygnus cargo spacecraft carrying about 7,500 pounds of research, crew supplies, and hardware to the International Space Station. The launch attempt on Sunday was scrubbed due to a problem with ground support equipment at the launch site. And following the scrub Sunday, Antares was drained of its fuel, and engineers worked to correct the ground support equipment that caused the scrub. Then on Thursday, it was rotated horizontally to freshen time-critical payloads aboard the Cygnus cargo spacecraft. The vehicle was then rotated back into its vertical position, but the launch attempt yesterday was scrubbed before fueling began due to high winds. Today, fueling for Antares began about 45 minutes ago and now stands ready to send Cygnus to the International Space Station. The winds are looking much more favorable for launch today, with temperatures around 36 degrees Fahrenheit. Joining me on console today is Chad Davis, Northrop Grumman's Human Systems Integration and Operations Manager. Chad, can you tell us a little more about what caused the scrub on Sunday and what the teams did to resolve the issue?
Sure thing. Good afternoon. Basically, with the Antares vehicle on Sunday's scrub that we had, we experienced an off-nominal reading on part of the ground support equipment, which tripped a limit sensor. And so, in the precaution and per the flight rules, they went ahead and scrubbed the launch since we were that far into the countdown in that very close time to T-minus 3 minutes or so. And since that time, the crew out there with the Antares as well as the Cygnus team worked very hard to go ahead and take that equipment, replace it, do thorough testing of it to make sure we were good to go for today's activities. Actually, we're good to go for yesterday's activities had the winds been on our side. And also part of that allowed the opportunity to refresh the cargo that we talked about back on Sunday on that capability.
So with those issues now behind us, the teams in the Launch Control Center in Wallops Island, Virginia, those Northrop Grumman teams are monitoring systems on the Antares rocket and Cygnus spacecraft to ensure all systems are a go for launch today. Teams are reporting that all systems are in good shape up to this point for an on-time launch at 2:21 p.m. Central Time. And once Cygnus reaches its preliminary orbit, controls of the vehicle will be handed over to teams at Northrop Grumman's Mission Control Center in Dulles, Virginia. Teams are being led by Mission Director Zach Dwyer. Again, as soon as Cygnus separates from the rocket today, controls of that vehicle will be handed over to the flight controllers there in Dulles. And back in the International Space Station Flight Control Room in Houston, Texas, flight control teams are being led by Flight Director Ron Spencer. Teams here are monitoring systems on the International Space Station, ensuring all systems are a go for Cygnus launch today, working in tandem with teams in Dulles.
3, 2, 1, mark.
And I copied that.
Cygnus will arrive to the International Space Station after a 3-day journey on Tuesday, February 18th, where it will be installed on the Unity module's Earth-facing port. NASA's flight engineer Drew Morgan will use the Canadarm2 robotic arm to grapple the Cygnus spacecraft, backed up by Jessica Meir of NASA. Once the astronauts have captured the vehicle, they'll turn controls back over to teams here on the ground in Mission Control Houston, where the robotics officer will use the Canadarm2 to reposition the spacecraft and bring it toward the Unity module to install it to the International Space Station. Cygnus will remain attached to the station until May 11th, when it will depart the orbiting laboratory and complete some satellite deployments and additional objectives before disposing of several tons of trash during a fiery reentry into the Earth's atmosphere on May 25th. Just 2 weeks ago, Northrop Grumman's Cygnus cargo vehicle from its 12th resupply mission, named the Alan Bean, departed the International Space Station after its 88-day stay. So when the 13th resupply mission launches today, Northrop Grumman will perform dual Cygnus capability for a 2-week period before its deorbit burn on February 29th. Still joined on console today by Chad Davis, Northrop Grumman's Human Systems Integration and Operations Manager. Chad, can you explain how Northrop Grumman teams manage two vehicles in flight at once?
Yeah, sure. We had developed the capability back whenever we knew we were going to fly the NG-11 vehicle for the extended period of time, and knew that that would overlap with the NG-12 mission. So the teams in the Mission Operations Center, as well as our ground segment folks, developed the software needed to be able to clearly identify two separate vehicles, so you knew which vehicle you were commanding and flying. And we went through multiple simulations to verify all those capabilities. And then we got the chance at the end of the NG-11 mission to test it out on 12, which now at this point, it's sort of standard operating procedure how we do it from this point going forward with future missions.
And each Cygnus spacecraft is named after influential individuals in the world of spaceflight, and the Cygnus spacecraft for this space station resupply mission is dedicated to U.S. Air Force Major Robert Lawrence, who was the first African-American astronaut selected by any program specifically chosen for the Air Force's Manned Orbital Laboratory program in June of 1967. Lawrence died in an F-104 Starfighter aircraft accident at Edwards Air Force Base 6 months later at the age of 32.
External power on.
FTS external power nominal. LC elect 2, FTS is safe, configuration verified, check channel being received.
Scattered clouds for launch back at the Mid-Atlantic Regional Spaceport at NASA's Wallops Flight Facility in Virginia. Temperatures now about 36 degrees Fahrenheit.
LC Ops 1, FTSA and B, internal power on. FTSA, external power off. And B off. IRIG is 195210.
Going up on Cygnus today is about 7,500 pounds of research, crew supplies, and hardware. Within that cargo is 1,570 pounds of crew supplies, 2,129 pounds of science investigations, 179 pounds of spacewalk equipment, 3,501 pounds of vehicle hardware, and 66 pounds of computer resources.
LC elect 2, FPS arm indication received, FPS is currently indicating safe.
And FSO verify FTS arm indication.
FTS arm indication.
LC.
And Courtney, I'd like to add to that manifest some fresh fruit. That was part of the changeover as they did the refresh. So the crew will be getting some fresh fruit and vegetables. I'm sure they'll be excited to see when Cygnus shows up.
Close ME2 VPG.
MES1 copies.
Now about 27 minutes and 30 seconds from launch today. All systems are still on track for an on-time launch today at 2:21 p.m. Central Time, 3:21 p.m. Eastern. Teams have been running through some pre-launch milestones today, which began about 4 hours ago with the poll for the launch vehicle to be powered on, and just about an hour ago, fueling for the first stage began. There have also been various checks between flight controllers here in Houston and Dulles, Virginia, to ensure everything is on track for an on-time launch today. Again, still on track for that launch, set to start at 2:21 p.m. Central Time, 3:21 p.m. Eastern.
We have a hot mic on countdown 1.
I'll keep going, I can.
Some upcoming milestones. About 12 minutes from launch, flight controllers will conduct a poll to proceed with the final launch countdown. In about 5 minutes from launch, the vehicle will switch to internal power. Then just about 3 minutes and 30 seconds before launch, auto sequence handoff for terminal countdown will be initiated. That'll mark the time the computers take over for the final milestones before launch. Approaching the 25-minute mark before launch.
And launch team LC, countdown 1, currently at T-minus 25 minutes and counting. And Prop 2, I want to proceed with step 367 at this time. You go to place OCCS in the SAC mode, pause the HSS ASC.
Prop 2 copies. LC Prop 2, HSS ASC paused.
And Prop 2, configure HS RP valve for final countdown.
LC Prop 2, 8021 opened.
Roger that. Prop 2, Prop Lead, verify EHS RP valve configuration.
LC, this is Prop Lead. EHS RP configured for final countdown.
Roger that. Lead in Prop 2, you can resume your HSS ASC and return OCCS to automatic control mode.
LC Prop 2, HSS ASC resumed, OCCS in auto control mode.
Copy that. 2, we'll go ahead and check 370 and 371 and GNC1 LC on countdown 1. Can you provide status of upper level winds?
LC, GNC1, upper level winds are go.
Copy that, GNC1. We'll check 372. Ops 1, LC, countdown 1. Step 373, you're go to enable ME1 and ME2 TVC and EHA buses.
LC Ops 1 in work. LC Ops 1, TVC and EHA buses enabled.
Roger. Ops 1, we'll check 373 complete. Site control LC, countdown 1.
Site control, go ahead.
Yeah, let's press with step 374, arm tel for rapid retract.
Copy that and work.
Now just under 22 minutes away from liftoff, and all systems are still on track for an on-time launch today.
And launch team, be advised, we are going to be waiving a constraint here. We'll get that briefed out in just a minute. At this time, I actually want to get a readiness for recalibration of engine pressure sensors. It's step 376, MES1. Yeah, MES1 on countdown 1.
MES1, countdown 1.
Yeah, MES1, I'd like to go ahead and get a recal of the engine pressure sensors. Are you ready for that?
Yeah, we're go for that.
EHS1?
EHS1 is go.
Copy that. Ops 1, step 377, recalibrate engine pressure sensors.
LC Ops 1 in work. LC Ops 1, engine pressure sensors recalibrated and ready for flight.
Copy that, Ops 1. Check 377 complete. And Ops 1, let's proceed with step 378, activate arm enable.
LC Ops 1, arm enable rotated, arm enable illuminated.
And arm stage 1 controller ODM.
Stage 1 controller ODM armed.
And set your stage 1 controller EPVV refs.
LC Ops 2. Stage 1 controller EPVV refs set.
Copy Ops 2. Check 378, 379, 380 launch team. We've just passed our T-minus 20-minute mark and counting. We are going to be briefing out a waiver here in just a minute. I believe we have our management concurrence. And system LC on countdown 1.
LC system here.
Yeah, you go to coordinate final adjustment to the payload ECS temp point to target fairing air temp. If you would go ahead and use anomaly 2 to perform that with site control.
Copy. Copy and work.
LC, this is site control. Step 374 is complete.
Do that, site control. TEL, LC countdown 1.
LC TEL.
Yeah, can you confirm TEL armed for rapid retract?
TEL is armed for rapid retract.
Roger that. We'll check 375 complete.
LC system, countdown 1.
Go ahead, system.
Yeah, step 381 complete.
Copy that. We'll check 381 complete. And launch team, that does complete all of our steps in our propellant loading operations, currently at the start of our propellant top-off.
And launch team, this is LCA on countdown 1. Be advised, we do have engineering recommendation and launch director concurrence to waive the engine pre-burner surface temperature constraints. Those are constraint IDs 10.024, 10.025, and 10.026. Again, we'll be waiving constraint IDs 10.024 through 10.026 for the remainder of the countdown.
Now 17 minutes from liftoff, and all systems are still a go for an on-time launch today at 2:21 p.m. Central Time.
And properly, I'll be waiting for your call on step 382.
LC, this is prop lead.
Go ahead, prop lead.
Yes. F1 N level is 11.
Copy that. Core 1, provide recommendation to F1 N level.
LC standby.
Cygnus, CMD, LC, countdown 1.
CMD.
You go to transfer Cygnus to internal power and report when complete.
In work.
at T-minus 15 minutes and counting.
LC, Core 1 on countdown 1. No fuel adjustment is required.
Copy, Core 1. We'll check step 383, prop 2. Configure OCCS for no adjustment to fuel level.
In work.
And prop lead, perform, step 385 will not be required.
LC, prop 2, OCCS configured for no adjustment to fuel level.
Copy that. We'll check 384 complete. And launch team, we're about 2 minutes away for our final poll. We'll proceed with our final countdown today. Ops 2, LC, countdown 1.
Go ahead, LC.
Let's go ahead and initiate step 387. You can initiate FIV position override.
Override complete.
Copy that, Ops 2. We'll check 387 complete.
Again, we're standing by now for that 12-minute mark before launch, where flight controllers will conduct a poll to proceed with the final launch countdown.
About 1 minute from our final poll. Today, I want to give kudos out to our Ops 1 and Ops 2 team today. And Franz, it's almost time to say goodbye to Hans. And CMD, do you have status on internal power?
Yes, we're on internal power nominal.
Copy that, CMD. We'll check 386. Okay, launch team LC, countdown 1, step 388. Poll to proceed with final countdown. GSO?
GSO, go.
RSO?
RSO's go.
TD?
TD's go.
Prop lead?
Prop lead is go.
Stage 1?
Stage 1 team is go.
MES1?
MES1 is go.
GCE?
GCE is go.
ACE?
ACE is go.
Mars?
Mars is go.
CMD?
CMD is go.
LD?
LD is go.
And NG?
In honor of Major Robert Lawrence, whose courage and sacrifice in the name of space exploration will inspire generations of people from all backgrounds to reach for the stars, Northrop Grumman is go.
And I copy that, NG. We'll go to proceed with final countdown. And launch team, be advised, step 389 will not be required, and step 390 will not be required. Step 391 will not be required.
You just heard the poll to proceed with the final countdown to launch, and all teams are a go. Just under 11 minutes now from launch, and everything is still proceeding smoothly for an on-time launch at 2:21 p.m. Central Time, 3:21 p.m. Eastern. Once we get to that launch time, the first thing that will occur is the Stage 1 ignition, and you'll see liftoff just a few seconds after that. And those two main engines will burn for about 3 minutes and 28 seconds before cutting off, and Stage 1 will separate. Cygnus will coast for a bit until fairing separation, when the external cover that protects the spacecraft during launch will separate.
Countdown 1, we're going to go ahead and perform the main engine FIV opening checklist. You are go to proceed on steps Q1, Q2, and Q3.
And Ops2 copies. Opening VZD on my mark. 3, 2, 1, mark. And IR time 2010-52.
Copy Q1.
The interstage adapter that connects the first and second stages will separate at 4 minutes and 14 seconds into flight before Stage 2 ignition, which is a solid rocket fuel that will burn for 2 minutes and 43 seconds. Once the second stage burns out, we'll be listening for the call of orbital insertion at 7 minutes and 4 seconds after launch. The vehicle will coast for 2 minutes before Cygnus separation at 9 minutes and 4 seconds after liftoff. At the time of launch, the International Space Station will be flying 258 statute miles over the Western Pacific. Then solar array deploy is expected to occur just about an hour and 19 minutes after launch.
And Ops 1 LC, countdown 1.
Go ahead, LC.
Yeah, let's kick off step 392. You go to enable your ACS VDMs.
LC Ops 1, ACS VDMs, internal power on.
How do you turn it on speaker?
ACS VDMs enabled, voltage nominal, ODM commands clear.
Copy that, Elec 1. We'll check 392 and 393. We have a hot mic on countdown 1.
So this is the official countdown. Oh, okay. This is what Daniel's logged in.
LC, Ops 2, VRG activated.
He said if you turn that one off.
Copy Ops 2, hot mic on countdown 1.
And publicly. This is the internal control panel. No.
LC Ops 2, VZD closed.
LC site control, GN2 conditioning initiated.
Copy that, site control. We'll check 394 and Q3. And MH1, report FIB position status.
LC MES1, FIB is indicating open.
Okay, copy that, MES1.
Yeah.
And Ops 2, you go for Q5, deactivate BRG.
Yeah, I turned it off. We're just here looking.
BRG deactivated.
Copy all. That completes our main engine FIB opening checklist.
Okay, we turned it off. Yeah, we did. We hung up.
LC, prop lead, VPSO activation verified.
I copy that, prop lead. Ops 2, step 396, initialize ground ordnance power supplies.
Ground ordnance power supplies initialized.
And ground ordnance power supplies nominal.
Copy that, Elec 1, check 396 and 397.
LC site control, AFBA ECS transfer to GN2 confirmed.
Roger that, site control. Check 398. And step 399 is not required for today's operation. And launch team, we're at T-minus 5 minutes and counting. Ops 1, step 400. You go to transfer avionics to internal power.
LC Ops 1, avionics internal power on, stand by for command completion. external power off.
And LC Elec 1, internal power is nominal.
Roger that. Elec 1, Ops 1, you can open your FTS umbiloop and verify green indication.
LC Ops 1, FTS umbiloop open and green.
LC Elec 2, FTLU and FTS receiver indications are nominal.
Roger that. Elec 2, Ops 1, step 404, send all armed command.
LC Ops 1, all armed command sent.
LC Elec 1, SNAs, ODMs, all armed.
Copy. Elec 1, we're at T-minus 4 minutes and counting. NASA TD, report range status.
Range is green.
Roger that. TD, range is green. And launch team, be advised, step 407 will not be required for today's operation. And we're passing T-minus 3 minutes, 30 seconds. Phase 3 dynamic limits will be active at T-minus 3 minutes.
FC command into flight mode. Auto sequence start. ODM bus voltages and currents nominal.
Roger that. Elec 1, GNC 1, verify ready for nav mode.
LC GNC 1, orb nav ready for nav.
Ops 2, switch to nav.
LC Ops 2, switch to nav.
LC GNC 1, orb nav telemetry verified.
Roger that. GNC 1, check 415. And launch team, we're passing T-minus 2 minutes. And T-minus 1 minute, 30 seconds. Mark. And T-minus 1 minute. Mark.
"40 seconds until liftoff."
T-minus 30 seconds. Mark.
"20 seconds till liftoff."
T-minus 10. 5, 4, 3, 2, 1.
We have engine start. Liftoff Antares, NG-13 mission from Wallops Flight Facility. Engines at 100%. Attitude nominal. TVC's nominal. Core pressures are nominal. Engine chamber pressures are nominal. Attitude nominal. Power subsystem nominal. Altitude 10,000 feet. Attitude nominal. Core system performance nominal. Engine and TVC systems nominal. Velocity 1,100 feet per second. Attitude continues nominal. Max Q, attitude nominal. Power subsystem continues nominal. Altitude 50K feet. Engine steady 100%. Core VNG3 activated. Attitude nominal. 3,000 feet per second. Attitude nominal.
Coming up on 2 minutes into the flight, they've passed maximum dynamic pressure on the vehicle.
Engine and TVC system remains nominal. 100,000 feet altitude.
2 minutes into flight.
Core pressures nominal. Engine steady 100%.
A minute and a half to go in first stage performance.
Attitude nominal. 150K feet altitude. Engine steady. Pressures nominal. $8,000 feet per second. Core pressures are nominal. Engines at 100%.
Coming up on 3 minutes into flight.
Low throttle down initiated. MECO slew maneuver initiated. Attitude nominal. Engines at 55% and nominal. $14,000 feet per second. Main engine cutoff.
Main engine cutoff confirmed. Standing by for stage 1 separation.
Upper ACS enabled. Stage 1 SEP.
Stage 1 separation confirmed. The next milestone is fairing separation, which will come in about 40 seconds.
Altitude 100 kilometers. Roughly 15 seconds to stage 2 ignition.
Fairing separation confirmed.
Fairing separation.
4 minutes into flight.
Interstage separation.
Interstage separation confirmed.
Attitude nominal. Stage 2 ignition.
And stage 2 ignition is confirmed. Stage 2 is that solid rocket fuel that will burn for about 3 minutes and 43 seconds. Burnout will come about 7 minutes and 9 seconds into flight.
Stage 2 will burn for roughly 2 more minutes. Power subsystem nominal. Stage 2 attitude nominal. Stage 2 TVC system performance nominal. Power subsystems continue nominal. FTS nominal.
FTS.
TVC nominal. Roughly 100 seconds till stage 2 burnout.
2 sekundy. Stávaš na prvý stupeň.
Vehicle systems nominal. TVC system performance nominal. Attitude nominal. Roughly 1 minute to stage 2 burnout. 6 kilometers per second velocity, 183 kilometers altitude.
Hot mic on countdown 1. Hot mic.
Vehicle performance nominal. Good attitude. Good power subsystems. 30 seconds to stage 2 burnout. System continues to perform nominally, heading into burnout. Stage 2 burnout.
Stage 2 burnout confirmed. Cygnus now moving about 16,822 miles per hour.
ACS enabled. Beginning maneuver to acquire payload separation attitude. Power nominal. The vehicle will continue to coast until conditions are met for payload separation.
Cygnus separation will come about 9 minutes and 4 seconds into flight.
Attitude nominal, roughly 1 minute to payload separation. ACS and power subsystems nominal, attitude nominal. Altitude, 197 kilometers. 30 seconds to payload separation. Vehicle subsystems continue to operate nominal. Roughly 15 seconds to payload separation.
Welcome to Verizon Wireless. The wireless customer you called is not available at this time. Please try your call again later. Announcement 1, switch 170-3.
We have payload separation.
Welcome to Verizon.
And spacecraft separation confirmed.
Called is not available at this time. Please try your call again later. Announcement 1,
beginning
switch
C-cam maneuver.
170-3.
And Cygnus is now on its way to the International Space Station, where it will arrive in 3 days on Tuesday, February 18th. I'm still joined on console here by Chad Davis of Northrop Grumman. Chad, what will the Northrop Grumman teams do here on the ground until Cygnus arrives to the space station?
From this point moving forward, now that Cygnus is separated from the upper stage, the team in MCC Dulles that we saw earlier, Zach Dwyer, the current mission director, followed by Paul Brower, the second shift mission director, will be making sure all the systems are nominal, going through, getting the solar arrays deployed, initializing the prop system, and essentially starting to play catch-up with the International Space Station.
And looking forward to Cygnus departure on May 11th, Cygnus will perform some secondary operations. Can you go over some of those?
Sure. Yeah, once we depart the ISS, we typically perform a burn to climb up to a little bit higher altitude, and then we have different payloads on board. Microsat, CubeSat deploys we typically do, and for this particular mission, we have the Sapphire, or the fire experiment that we talked about on Sunday, provided by the Glenn Research Center, and we'll actually set off that experiment to measure different interactions of fire and microgravity, and that will occur inside Cygnus post-deploy. So those are two of the main activities that we do, along with some other what we call lessons learned that we gain more and more experience flying the vehicle.
All right, Chad, thank you for joining us today, and here shortly we'll be talking to Joel Montalbano, International Space Station Deputy Program Manager.
Thanks for having me.
Now joining me on console is Joel Montalbano, International Space Station Deputy Program Manager. Joel, thanks for joining us today.
Oh, my pleasure. It's great to be here. Awesome launch today.
Cygnus is in orbit en route to the station for its arrival on Tuesday, so how important was today's launch in terms of continuing resupply of the station and the science it is delivering to the crew on board?
You know, we meticulously plan every one of the missions going to the International Space Station, and today's mission is no different. We have hardware on board that will continue the robust science and research program we have on board the space station. We also have equipment on board that will continue the development of commercialization of low Earth orbit. And we have hardware on board that helps us in exploration. It helps us buy down risk for the Artemis program as we return to the moon and go even further.
And the Northrop Grumman flight control team continues to be busy managing Cygnus's launch today, its journey to the station, and the previous Cygnus that will remain in orbit for the next 2 weeks, serving as a science platform. How impressive is the ability of these commercial flight control teams to multitask in support of station operations?
You know, we have a really good relationship with Northrop Grumman and all our domestic partners and international partners, and and it's a partnership. We work together to, one, fulfill the NASA contract that we have with these companies, as well as to help them meet their company objectives on board. For one example is this mission was scheduled about 2 months from now, and NASA had the need to move it up. We worked with the Northrop Grumman team. We were able to move it up into this time frame, and what you saw today was just an awesome launch and a result of some of that work and an example of the great partnership we have.
And no time to rest for the station program, with SpaceX almost 2 weeks from its next cargo run to the station and a Soyuz crew rotation to follow in the early to mid-April timeframe. As always, how complex will the next few months be for the station program and the global partnership?
This year we're going to celebrate 20 years of continuing human presence aboard the International Space Station. And one of the coolest things about working on Space Station is the next 2 months are always busy. Following this launch today, we'll have a berthing early next week. Looking forward in March, we'll have a SpaceX cargo mission launching to the International Space Station. Going to April, we'll have a Soyuz mission bringing 3 new crew members. And then mid-April, Soyuz landing, bringing 3 crew members home. Fast forward a few weeks after that, we'll have a Japanese cargo mission bringing critical batteries to the International Space Station that allow us to continue our upgrade of our power system. In addition to all that, we're working with SpaceX and Boeing to launch crew members from Kennedy Space Center this year. We plan to have both of those missions visiting the International Space Station. And on top of all that, we do our daily job of the research and science we do on board, the exploration objectives I talked earlier, as well as work to commercialize low Earth orbit. So just an awesome time to be working on the International Space Station. And these 2 months and the future 2 months are always going to be busy.
All right, Joel, thanks for your time today, and thanks for joining us here on Console.
My pleasure. Thank you. Congratulations, everyone, on a successful launch.
Just to recap, Cygnus lifted off from NASA's Wallops Flight Facility in Wallops Island, Virginia at the Mid-Atlantic Regional Spaceport, Pad 0A, on time today at 2:21 p.m. Central Time. 3:21 p.m. Eastern to begin its journey to the International Space Station. So again, Cygnus lifted off from NASA's Wallops Flight Facility in Wallops Island, Virginia at the Mid-Atlantic Regional Spaceport, Pad 0A, on time at 2:21 p.m. Central Time, 3:21 p.m. Eastern to begin its journey to the International Space Station, where it will deliver about 7,500 pounds of research, crew supplies, and hardware. At the time of launch, the International Space Station was flying 258 statute miles over the western Pacific, northeast of the northern Mariana Islands. Solar array deploy is expected to occur about an hour and 19 minutes after launch, so within the next hour, if all goes as planned, Cygnus will complete its solar array deployment, which will take about 30 minutes, and once that activity is complete, we will update the station webpage on nasa.gov. With Cygnus now on its way to the International Space Station, we hope you'll join us back on air when Cygnus arrives to the station in the early morning on Tuesday, February 18th. NASA's television coverage for Cygnus arrival and capture will begin at 1:30 a.m. Central, 2:30 a.m. Eastern Time for a capture around 3:05 a.m. Central, 4:05 a.m. Eastern. Then we'll be back on air at 5 a.m. Central, 6 a.m. Eastern for Cygnus installation operations coverage. With Cygnus now safely on its way to the International Space Station to deliver about 7,500 pounds of cargo, that'll wrap up our coverage for today. This is Mission Control Houston.